questions. That way I can see it. Last week I was like hiding it, but then I lose all the controls. So I'm just going to move it out of the way. And if you need me to move it, go ahead and tell me. I want to know. Okay. So this lesson is called dividing a line segment based on a ratio. And I've got some apples and pears here on the screen. I wanted to ask to get you started thinking about this. What is a ratio? It's a tough one. You've heard it. You've probably maybe even used the word or thought about it before. You've heard about it in the news or in math classes or in other areas of life. When we make recipes, if you're following a recipe to make something to eat, there's ratios involved. Maybe it's not a recipe on the back of the can of pumpkin pie filling or something. Maybe it's a recipe that you got from a family member or something, and they say to do a 1-to-3 ratio of salt to flour or of sugar to flour or something like that. So let's think of a ratio as a way to compare numbers. Here's the definition I found that I wanted to use with us. Ratios are a way to compare numbers or quantities. That's basically what we're doing with a ratio. They tell us how much there is of one thing compared to another. And then lastly, folks, we use I think this is a colon symbol to separate the numbers being compared. So for a quick example, let's look at our apples and pears. We want to compare those two numbers of how many apples, how many pears. So apples to pears. Well, how many apples do you see? The red ones? There's 6. You see those 6 red apples. And how many pears? There's 3. We use our colon to separate the two numbers. So we could say as a ratio for these apples and pears, they are in a 6-to-3 ratio. Or a 6-to-3 ratio. That's how we read that when it's with the colon, a 6-to-3 ratio. And of course, we also do want to simplify or reduce the ratio just like we do a fraction. So because we could divide 6 and 3 by the same number, we're going to do that to make it a simpler ratio. So we would actually call this a 2-to-1 ratio. For every 2 apples, there is 1 pear. Oops, there we go. For every 2 apples, there is 1 pear. That's what the ratio is telling us. And I just randomly picked to start with apples. Let's say the problem was reversed and they wanted it to say pears to apples instead of apples to pears. Well, then we would still count up pears and apples. We would just present them in a different way. So if we were talking pears, you would say it's a 1-to-2 ratio. For every 1 pear, there are 2 apples. But the numbers are the same, right? It doesn't change how many apples and pears there are. Now, this is a fun, cute, simple example with my fruit, right? We're going to be using the idea of the ratio with line segments. That's our real goal for today. But I think it's easier to start with this example first before we jump into the others. Any questions or comments on this example and using ratio and how I got the 6 and 3 or the 2 and 1? Please, can we talk about that before we move on? Any questions? If there's no questions, let me really quick see your guys' thumbs. Give me a self-assessment. I'm a thumbs up, thumbs sideways, or thumbs down with this idea so far. Just quickly turn on that camera for me and show me your thumb. Where are you at so far with this example? Aaron, thank you. I appreciate the feedback. How would you rate yourself on this idea of the ratio? Maria Celeste, thank you for the feedback. If you want to type in the chat, you can't use your camera, we'll do that. But I need to have some feedback from you guys where you're at so far. Andrew, I see that. Thank you. Let me get this out of the way. I'll make it a little thinner there. All right. So the rest of you, I hope you're doing okay. I would like to know where you're at. Delaney, Bailey, Manaya, and Antonio.
I'm doing good.
You're doing good? Okay.
Yeah.
With this ratio idea?
Yeah, I'm like in the middle of it. Like I'm in the middle, somewhat okay, but somewhat not.
Maybe we should do another like simpler comparison first, so we can just get another example. Okay, guys. So let's do this. I'm going to throw in something else. I didn't have it ready, but it's cool. I don't want to leave everyone behind. Hang on. Okay. Oh, some chats. Andrew, same. Okay, Antonio, thank you. All right, so let's try another quick example here. Let's say we had, I don't know, some marbles. Okay, so we've got red marbles. Okay, there's 4. And we'll have some purple marbles too, as well. Okay, can you guys see those? 4 reds, 3 purples. I've got my marbles in a bag. Okay, what is the ratio of purple to red marbles? How do we figure this out? How do we state the ratio? What is the ratio of purple to red? It's simply comparing the two numbers. So how many purples do you see? 3, right? So we start with that one. Why did we start with that? Because the way I asked it, it's the purple first, and then it's the red. So we're going to say it's 3 dot dot to the red marbles. And how many do you see for red? 4, right? So the ratio of purple to red is 3 to 4. Three to 4. That's how we say that. 3 to 4. Meaning for every 3 purples, we've got a group of 4 reds. Let me check your guys' chats. Beautiful. Antonio, nice. Antonio, you got the right idea. You'd set it up correctly the first time, 3 to 4, but we can't reduce 3 and 4. We can cut 4 in half. We can't cut 3 in half and get like a whole number. So because it's we can't divide 3 and 4 by 2 or some number together, we're going to keep this one as 3 to 4. Now the last one I did divide in half because we had 6 and 3 for the fruit, 6 apples and 3 pears for the first page. Now, because I can divide 3 by 3 and 6 by 3, we're basically doing this, where it's like reducing a fraction. So we would end up with 2 to 1 for apples and pears. Is it wrong to say 6 to 3? It's not incorrect. It's just not reduced, okay? So this is still correct and true. But down below, if we reduce it, that's a little cleaner, and that's what you're going to see in the world and other math classes. This is just cleaner and reduced. So it's still correct if you use the original numbers, folks, but we will need to be ready to reduce the fractions, reduce the ratio. I hope that's helpful. But nice job, Antonio. Thank you for sharing what you got for this one, because you did. I can see you're on the right track and you're getting the idea. So when we do our ratios, folks, it's simply a matter of how much in one group to how much in the other group. Side note, how many total dots or marbles did I make? The total was 7, right? total is 7. And every time you set up your ratio, that your two numbers should add up to the total. So look below, we had 3 to 4. These add to 7. That makes sense because there's 7 total. Okay, so that's another thing you can do to check yourself and make sure you've set it up right. They'll add up to the total number of items. If we do that with the pears and apples, let's go back to the beginning here. So how many total fruits are there? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 total fruits. And the way we initially set it up was 6 to 3, and 6 plus 3 is 9. Now we reduced it. So when we reduce it, that changes the total, but you can check the total when you first set it up. When you first make it as 6 to 3 before we reduced it. Awesome. Okay, so we're going to be doing this today, but we're going to be doing it with line segments. Okay, oops, I just unmuted myself. We're going to be doing it with line segments. So let's see an example breaking a line segment up and using the idea of ratio, okay? How do we use ratios to describe segments of a line? Let's do that now. So let's say we had some generic line segment floating in outer space like this. Line segment AB. Okay, and we don't know how long this is, okay? All we know is it goes from point A to point B. Let's suppose it was being cut off at a certain place or at any randomly chosen place, like right here. I'm going to call this point point C. So now I've taken original line segment AB and we've cut it into two smaller chunks from A to C. And next to that, we've got from C to B. Two little chunks or two smaller chunks, they add up together to make the original whole AB. So we're going to be doing this with our line segments. The ratio, let's say that AC, we label that as little a, lowercase a, and we'll call the next segment lowercase b. So think about it this way. Little a plus little b adds up to make the entire segment, right? AB, the segment AB. So here's something I want you to have in your notes. Make sure you have this diagram I've made so far. We're going to be using this and expanding on it. If the whole segment is AB long, A plus B long, then what's the proportion? What's like the section of AC? It's A over A plus B. So the first section, AC, this is A over A plus B, length of the whole, AB. And then let's look at the next section, CB. CB, well, it's not little a, it is little b. That's how long it is. So it is little b over a plus b length of the whole. Please write this down in your notes. I want to do another example in just a moment with actual numbers so we can kind of put this together with our oranges and pears or apples and pears from the beginning. Connect it to the ratio idea. Okay, I'm going to wait another 10 seconds and then we're going to put some values, some numbers to this example. And then we'll see it hopefully make a little more sense looking at sections of a line segment like this. Okay. So same segment, let's use AB. And I'm going to make my C point right about here. Now, let's say that we purposefully put C in that location. It's not just random. So let's say that this is 1/3 of the whole AB. And then we cut another third right here. Let's make that point D. So from A to C is 1/3. From C to D, that's another third. And from D to B, that's another third. They're all the same length long. Let's say that AB is 12 units long. So suppose that from A to B is 12 units, 12 inches or 12 feet or 12 miles, the whole thing, 12 units. Okay. Well, if we have set up these chunks to be 1/3 long each, from A to C is a third, C to D is a third, and so forth, then how long is AC? How can we find that? Well, we've already figured out that this proportion, this fraction of the whole is 1/3. AC is described as 1/3 of the entire whole AB. So I'm going to multiply 1/3 times the whole, 12. I see something in the chat. Thank you. Good. Thanks, Antonio. And if you multiply the chunk 1/3 by the whole 12, we get 4. How did that math work, just in case? Remember, whole number like 12 can multiply to the numerator 1. So we get 1 times 12 over 3. 12 over 3, divide it, and we get 4. Now, I still haven't really used a ratio here, but we have set up a line segment, and we've used chunks, certain measured chunks, the 1/3 chunks, to find how long the smaller sections are. So AC is 4, and CD would be 4, and DB would be 4. Notice that if you add those up, it adds up to 12. So each smaller chunk, if you add all the smaller chunks together, that it equals the whole. We could write a ratio to show this as well. So a ratio for this example, you could say, what is the ratio of, let's just say, AC to AB, the entire thing? Well, look at the numbers and treat them like we did our fruit at the beginning. AC is 4 long. AB is 12 long. So we could say it's 4 to 12. If we reduce this, you could divide 4 and 12 by 4, and that gives us 1 to 3. Interesting, 1 to 3 showed up earlier too as 1/3. So there's kind of a relationship between writing the proportions, the 1/3 fraction, and then the ratio comparing how long is AC to AB. Well, it's 4 to 3, or it's 4 to 12, otherwise known as 1 to 3. Okay, comment in the chat. Oh, Keegan, I'm glad you're here. Although it is 10:25. Okay, so at the end, Keegan, I'll put up the first two screens we were on before we got to this. Folks, now I want to ask another question. We're going to expand on this idea. Notice how to find out how long, going back to my question here about AB and how long it was, or I'm sorry, AC and how long it was. That's this little chunk. I'm going to make it purple. So in order to find that, we multiplied this fraction, 1/3, times the whole. That gave us kind of a starting point to figure out how long AC and CD and DB are. We're going to do that. No problem, Keegan, no problem. We're going to do that now for another example. Okay, we're heading closer and closer to the main goal for today. Here's our main goal. We want to be able to find a specific coordinate that divides a line segment into a given ratio. So we're going to have a line segment, and we want to be able to find this exact point that cuts it into a certain ratio. Okay. So I'm going to use the same segment we've been using to show you where this formula is going to come from. So say again, we have segment AB. Now, say that we want to cut AB into a certain ratio. We want to cut AB into, let's say, 2-to-3 ratio. We want to cut AB into 2-to-3 ratio. So what I mean by that is I want to take the AB segment and cut it up into a chunk of 2 equal pieces and then 3 equal pieces. Oh, this silly thing. So how do we even begin with that? What is the total? Remember from earlier, what is the total of these two chunks, 2 and 3? The total, if we add those, is 5. So think about it this way. If we want to find a certain ratio, like we're told to find a 2-to-3 ratio of this segment AB, step 1 is to think about it as cutting the whole thing into 5 equal chunks, because these add to 5. So if we were able to perfectly cut this into 1, 2, 3, 4, 5. Now, you can see from my picture, I didn't do a very good job of perfectly eyeballing it, right, of estimating. But what we're going to learn in just a sec is how we can find a precise way to split this into 5 chunks. You see the 5 chunks there. So if we rely on just estimating, we're probably going to get it wrong. Like I'm going to get it wrong for sure, right? I can't just eyeball cutting this into 5 chunks. But there is a way that we can find precisely how big to make these chunks. And then how do I cut it into 2 to 3? Well, we want to just cut it into a group, a total of 5 equals, and then count off 2 of them. Boom, right there. So this point right here, if I made it precisely and perfectly, this would represent 2 because there's 2 chunks below it, to 3 because there's 3 chunks following it above. So from A to the red point is like our 2. This is like our 3, meaning this spot right here, that's 2 to 3. That's marking the 2 to 3 point, 2 to 3 ratio spot. So this spot marks the 2 to 3 ratio location or coordinate. Okay? That's what our goal is. Now, how are we going to go about finding that location? So there's a formula we're going to use. And once we get some practice with it, it won't be too hard, I hope, to run through the formula. So really today is going to be just using a formula over and over again for different questions, different problems. But I wanted you to hopefully have some understanding and comfort level with like where this formula comes from. So I'm going to add to this. So here we go. So point A at the bottom, point A, we're going to call that location X A, comma Y A. It's the X and Y for the A point. Point B is likewise going to be called XB, YB. Again, it's just the X and Y for wherever that B is located, right? And I'm going to call it B and B because it's the B point. Now, point C, where it's marking our 2 to 3, let's label that guy. So there exists a point C, right? And our goal is to find, well, where is point C? What is the actual location of it? We're going to call that spot XC, YC. And now, how do these different X's and Y's all relate to each other? So to find XC, this is important. Make sure you get this whole page, but definitely this part in your notes, along with the diagram. So to find XC, this is like starting from XA. So it's XA plus the correct fraction. Just like in the last example, we multiplied it by 12, right? Or I'm sorry, we multiplied it by 1 over 3 to find that distance, that length. So to write it this way, it's chunk A over A plus B. That's like measuring out. Let me change my color quick. Remember, little a and little b, that stands for this spread from A to C. That's A. And then from C to B, that's B. And when you add a plus little b, it gives you the whole length, right? So this fraction, A over A plus B, is basically saying the 1/3. It's like how much chunk of the total is this first slice from A to C. That's what this fraction is representing. We multiply that to the total, AB, but if we don't know the total, like in this example, we don't know the locations, then we're going to multiply it by XB minus XA. What that's doing is giving us from XA all the way over here to XB, it's giving us this chunk right here when we multiply it to the fraction. XB minus XA, as I've got it in dots at the bottom of my picture here, that's the whole spread from the first x coordinate to the second x coordinate, from A to B. So we're finding that whole length, and then we're multiplying it by the fraction A over A plus B. Okay, now we're going to look at the y coordinate, and it's the same thing that we already have, but for the y's instead of the x's. So I'm going to change back to red. So to find y of C, well, it's like starting from YA and adding to it the right proportion, A over A plus B, times YB minus YA. Okay, I'm going to put these in a box. These are super important. we're going to use this to find the exact coordinates of point C. And what is point C again? It's where we take, it's where we can cut the segment AB into the proper ratio that they want us to use. So I said 2 to 3. And we're going to do this now with some numbers. So I'm going to leave this on the screen for 10 more seconds if people are still writing. And if you need more time or have questions, please tell me now. So far, it's all good. If you have questions, I want to hear them. Other people will too. And then we'll try doing the same thing, but with some actual numbers so we can see it in play and how these formulas work. All right, there's no questions. Let's go ahead and try it with some real numbers now instead of like XA and YA and YB and all that. Here we go. Okay, example. Find the coordinates of point C, which divides line segment AB into a ratio of 2 to 3. So we're going to use the 2 to 3 ratio. And now it's telling us point A is 1, 1, point B is 5, 3. Great. So here's our segment. A lives at 1, 1, and B lives at 5, 3. Make sure to write this down. The goal here is to find point C and what are the coordinates of it. And it's going to cut AB and do a 2 to 3 ratio. So I'm going to mark it right here. But we still need to find, well, what is the coordinates of it? What spot on the graph does it live? Remember, this is XC, YC. So we want to find those two numbers basically. Okay, so using our formula, XC, I'm going to write it out blank again. XC is equal to XA plus A over A plus B times XB minus XA. Now it's just a matter of plugging in the numbers and simplifying it. What is the x coordinate of point A? Point A. Look down at point A. It's 1, 1, right? So that means the x coordinate is the first one right here. That's XA. So it's 1. So we're going to put 1 plus this stuff. Now, what is the little a and the little b? Well, we can take these directly from the ratio. So looking back above, the ratio they gave us was 2 to 3. The first number is a, the second number is little b. So for this fraction, a over a plus b, we're always going to use the ratio numbers. So this is 2 over 2 plus 3, a plus b, so 2 over 5. So 2/5. So what we're trying to find is what is the 2/5 mark along our line AB. So we're going to multiply 2/5 times XB minus XA. And what is that? That's 5. That's XB minus 1. Now we can simplify this. 5 minus 1 is 4. Okay, so this is not going to come out to a nice clean whole number, but it's okay. We can still solve it. Okay, so to simplify that fraction, we've got 2 times 4, so that's 8. So 1 plus 8 fifths. Let's go ahead and just do this in our calculators. So 8 divided by 5 will give us a decimal, and then we'll add 1. Okay, so 2.67. 1 plus 2.67. So it's 3.67. That, what we just found was XC. And we got to find YC now, the Y portion of point C. So we're going to use that formula. So here's the YC formula. All right, so what's YA? Looking over at A, the Y number is 1. Again, they're both 1, right? So that's going to be 1 again. The fraction that we made is the same one we use for both. So we got 2 fifths last time. It's still going to be 2 fifths this time. And then YB minus YA, so that's 3 minus 1. So do the subtraction first, and then multiply it to the fraction, and then add the 1. Add the number on the left. So this gives us 3 minus 1 is 2. So this time it's 2 times 2, so that's 4 fifths. So 1 plus 4 fifths. And let's just turn it into a decimal right away. 4 divided by 5, 0.8. Add 1 for 1.8. And that's YC. So those two numbers we found, that's the exact point. So 3.67 comma 1.8. That's the exact point that's cutting AB into a 2-to-3 ratio. This chunk is like 2 chunks, and this chunk here is 3, 2-to-3. A to C is like 2 equal chunks, and C to B is 3 equal chunks, for a total of 5. Okay, that's it for this example. I want to look at a few more directly from the mastery test with you, so you'll have some prep for that. The good news is there's no more to add on to this. So our goal for today is to be able to use these two formulas to find XC and YC. When they give you a line segment, some points for the ends, like A and B, and then we have to use our ratio 2-to-3. This one was 2-to-3, but let's look at others where it's not 2-to-3, it's some other ratio. Here we go. All right, so here, this is from our test. Drag the tiles to the boxes to form correct pairs. Not all tiles will be used. Interesting. So what we see in our diagram is we've got this long line segment A to B, and then they've got it cut into equal chunks already. A to C, and then there's point D, E, F, G, H, and I. Those little lines they've drawn right here, those are telling us that the segments are all equal. So from A to C, that's as long as it is from C to D, D to E, and so forth. All right, in the figure, AB is divided into equal parts. The coordinates of point A are 2, 4, and the coordinates of point B are 10, 6. Match each pair of coordinates to the corresponding point on AB. So they're basically asking us to find, if we look at our blue options below, we've got D here. So point D, what are the coordinates of point D? It's going to be one of these options that we have as coordinates, 9, 5.75, or 4 comma 4.75 or something. So we have to do the formulas for each one of the points. So for D, E, H, and I. So let's start with finding point D. So find point D. Now, before we start, because we do have most of what we need, we have XA and YA, and then we have also B, XB and YB. But they didn't tell us a ratio. How can we figure out our ratio for point D? We need like a number, colon, number to a number. Let's see how we can count that using the picture. They didn't tell us, but we can count it and figure it out based on the picture. So how many equal chunks does A to D have? It's got 1 and then 2. So this is 2 chunks. Well, how many chunks remain if we split our line at D? 1, 2, 3, 4, 5, 6. So the remaining chunks, if we're splitting it at D, is 6. So to find point D, we're using the ratio 2 to 6. And now can that be reduced? 2 and 6 can each be divided by 2, right? So this reduces to 1, 3. So we're going to try to find the location for point D using the ratio 1 comma 3. And then our points for the ends are A and B. We have those. Those won't change. So let's see. The X for D and the Y for D. We need to find those two locations. So it's the same formula we used before. XA, that's 2. Where did that come from? From the point A, the x coordinate of point A. Now for the fraction part, 1 over 3. Where did that come from? Our ratio. Oh, but it's A over A plus B. So it's A 1 over A plus B, which should actually make it 1 plus 3. Let me fix that. It's 4, 1 to 4. Good. Okay, and now we have to put the difference between point B and point A. Remember, it's like the B minus A at the very end. So x's, it's 10, xb minus xa, 10 minus 2. Okay, so now let's fix the parentheses, multiply it to the fraction, and then add it to that plus 2 at the left side. 10 minus 2 is 8. Multiply the fraction to the 8. So 8 over 4. 8 divided by 4 is 2. So we have 2 plus 2. We have straight up 4, a nice whole number. So xd is 4. So looking above at our picture again, we now know the x location for d is 4. We got to find the y. So now we're going to use ya. So remember, we're always starting from the left side and kind of adding from there. So we're using the y this time, which is 4, not 2. That was xa. Okay, the fraction can stay the same, 1 over 4. Where did that come from again? It's a over a plus b. So we have to, if they give you the ratio, you can use that as your a and b. But here they didn't give us the ratio. We had to count the chunks to see what the ratio is. So when we use d, it's 2 to 6. The total gives us 8. So 2 over 8 is where the fraction came from, 1/4. Okay, and then now we're doing the y's. Y of b, 6, minus the y of a, which is 4. Do the subtraction, multiply to the fraction, add it to the number on the left. 6 minus 4 is 2. 2 times 1 on top, that's 2 over 4. So 2 over 4 is a half. 4 plus a half. Okay, so this is not going to come to a whole number, but 4 plus a half is 4.5. And that is y of d. So now we have the point for d. It's 4 comma 4.5. And we see that as one of our options right here in the blue boxes. So that means we would match these up in Inventum. Let's look at another one. We're not going to have time to do all of them because we've only got a few minutes left. So let's skip down and try to find I. Let's do I. And we got to find its coordinates now. So looking at point I, way up here. So what's going to change? Find point I. What's going to change is our ratio this time. Change my color. So how many chunks is on the left of I if we kind of cut it across there? And how many chunks are on the right? Count them up. 1, 2, 3, 4, 5, 6, 7 from A to I. And then 1 from I to B. 1 equal chunk on the right, 7 equal chunks on the left. The total's still 8, right? There's 8 equal chunks total, but now we're splitting it with a different ratio. So we're asking to find a 7 to 1 ratio. So below here, look at the bottom of the screen, find point I. The ratio we'll use now is 7 to 1. So this is my new A and my new little a, little b for our ratio for the fraction. Can you guys see the bottom of my screen, or is it like cut off? Can you see the 7 to 1? It's cut off.
Yeah.
Perfect. Can you see the YD work that we did?
Yeah, we can.
You can see
Or
that.
I can.
Okay. But you can't see the 7-1 that I made.
Yeah.
Sweet. Are you on your phone or on your computer?
I'm on the computer.
Okay. One second. Maria Celeste, thank you. I'm glad you can see it. So I'm guessing some people can see this stuff and some it's cut off. If it is cut off, I would have totally appreciated if you guys told me. I'm assuming you guys could see it all. Let's do it now for point I. Same problem, same question. Okay, I'm assuming you guys can see this. We just found the ratio. We've cut it here. There's 7 chunks on the left, 1 on the right. So we're asking to find a 7 to 1 ratio. There's our little a, little b. Same formulas now. XA, XI, I mean. We're trying to find what is that location at I. And then we'll do Y, xi, and then yi. Okay. And again, a is 2 comma 4, b is 10 comma 6. Those aren't changing. We're going to use those again. So starting from point A on the left, and we want to add the proper amount to the right of it. So we're starting at 2 if we use our formula. This time our a over a plus b is changing. 7 over 7 plus 1. So that's going to be 7 over 8 when we add the bottom. Okay, and then 10 minus 2 for the x of b minus the x of a. 10 minus 2. So 7 over 8. 10 minus 2 is 8, right? So this time they cancel. 8 over 8 will cancel. If you do it the longer way, it'll still work out. 7 times 8 is 56. 56 divided by 8 is 7. So we've got 2 plus 7, or not 14, 9. Oh my gosh, sorry. All right. 9. And that's I, so the x for I. Okay, and now to find the y of I. This time we're adding from the y's, not the x's. So 4, and that's the y of a. Same fraction, so it's 7/8. 10 minus, sorry, not 10, 6 minus 4, because we're doing the y numbers this time. 6 minus 4. 6 minus 4 is 2. Cool. Okay, so now 7 times 2 for the fraction, that's 14 over 8. Let's go ahead and just divide right now because all of our answers are in decimals. So 14 divided by 8 is 1.75. So we've got 4 plus 1.75. So that should be 5.75. And that is the y of I. So the coordinate for I is 9, comma 5.75. And hallelujah, that's one of our blue boxes right here. So that means I would match up with this guy. All right, now I think it's time to go. It's almost 11. Let me really quick mark down who was here today. And I'm sorry there's not a lot of time for questions. Keegan asked, or I told the group I would go back to the first slide. So let's go there. We just started today by defining a ratio, and we did an example without any line segments or geometry using fruit to write a ratio. So we wrote apples to pears 6:3 because there's 6 apples and 3 pears. Okay. Anaya, Bailey, Aaron, Delaney, Keegan, Maria Celeste, Antonio, Andrew. All right. Now I wanted to get to more of the examples from Edmentum, but honestly, every question in Edmentum is going to be coming from the same place. You're going to either be given a ratio, like we were for the first big example, here. We were given 2:3 ratio, and then we use that for our fraction portion, a over a plus b. And every time you will be given the points for the endpoints, the big A, big B. then it's just a matter of using the formula from this lesson. So I'd like you all to try this mastery test. This is your homework for today. It's called using ratio, dividing a line segment based on ratio. Okay, tomorrow I want to do questions.